Hello, everyone. My name is Kohdai Kuroiwa. I'm a PhD student at Institute for Quantum Computing at University of Waterloo. Then today I will talk about general quantum research theories, maximal resources, catalytic replication, and consistent measures. This talk is based on these papers, and this work is a joint work with Hayata and Yamasaki at ICUC Vienna. So first, let me briefly introduce quantum research theory. Quantum research theory is a framework to investigate quantum phenomena and quantum properties such as entanglement and magic states in a unified way. In this framework, there are merely two aspects: manipulation of resources and quantification of resources. In the manipulation, we are interested in how we can transform resources using free operations as depicted in this figure. And then in the quantification, we are interested in how we can quantify resources using some mathematical functions that are called resource measures. While many quantum resources were investigated through the framework of quantum research theory, general quantum research theory has been recently formulated to figure out common properties shared among many resources. Then, however, some mathematical assumptions have been considered to make analysis tractable. For example, the convexity of the set of free states and the finite dimensional state space and the existence of unique maximal resources. While these assumptions are satisfied in some known QRTs, for example, QRT of reported entanglement, we'd like to point out simply extending a well-known framework is not necessarily sufficient. For example, non-Markovianity and Discord are known as non-convex resources, and then non-Gaussianity is a quantum resource which emerges in an infinite dimensional state space. And in the QRT for Q-treat, there are in the QRT of magic for Q-treat, there are no unique maximal resources. So we'd like to analyze the universal properties of quantum resources and the minimal axioms to cover quite physically motivated resources whose analysis is not necessarily mathematically tractable. For this purpose, we consider the following axioms as our minimal axioms. The first one is the state space and the set of state free operations are compact, which means that quantum states and the quantum operations are indistinguishable if they are close enough. The second one is identity map is free, which means that doing nothing is free. And then free operations are closed and the composition and the tensor product. So basically, we can freely use free operations anytime, any order, regardless of other systems. Then the trace out is free. So like ignoring a system is free. Under these assumptions, we have following results, and we have mainly three contributions in our work. The first one is we prove that maximal resources always exist, while, as we pointed out in the previous slide, they are not necessarily unique. The second one, we discovered a phenomenon we call catalytic replication, where a resource state can be infinitely replicable and free operations. The last one is consistent resource measures, which quantify resources without contradicting the asymptotic state conversion and the free operations. And then we proved that consistent resource measures exist all finite and convex QRTs and the QRT of Discord and non-Markovianity, and the convex QRT of non-Gaussianity under some appropriate energy constraint. So as a conclusion, we introduced a general framework that applies to a broad range of quantum resources, including those not satisfying the conditional assumptions, that is, physically motivated, but whose analysis is not mathematically tractable. For example, non-Markov entity, non-Gaussian entity, and Discord. So that is for my lightning talk. And if you have any questions, please reach out to me. Thank you so much.